Hello everyone, I am coming back after a long time and today I am going to discuss a problem related to the function analysis and which asked GATE-2020. Okay, so let's try to understand this kind of problem first and after that we will try to solve it. So look at this problem here. So this problem asked GATE-2020 and for n belongs to capital N, let Tn such that L1 to infinity and T such that L1 to L infinity be the bounded linear operator and defined by Tn x1 x2 dot equal to y1 y2 dot and where yj equal to xj and j less or equal to n and xn where j greater than n and capital D of x1 x2 dot equal to x1 x2 dot. So then first option, norm of Tn does not converges to norm of T as n tends to infinity, and second option, norm of Tn minus T, this tends to 0 as n tends to infinity, and third option, for all x belongs to L1, norm of Tnx minus T of x tends to 0 as n tends to infinity, and fourth option, for each non-zero x belongs to L1, there exists a continuous linear functional g belongs to L infinity such that g of Tn x tends to g of T of x as n tends to infinity. Okay, so this is the problem. So this problem also asked on the convergence of sequences of operator. So first we try to discuss the types of the convergence of sequences of operator. So I always start with how to solve. So how to solve? Okay. So definition: convergence sequences of linear operator. Okay, so first let x and y be two nonlinear space and Tn x be a sequence of the bounded linear operator, and this is belongs to B of x and y. Then number one, uniformly convergent operator convergent if Tnx converges in the norm B of xy. So that is norm of Tn minus T. So this is tends to 0 as n tends to infinity. And number two, strongly operator convergent if Tnx so this is your Tn, okay, not Tnx. Okay, so this is your Tn converges in the norm B of xy, and strongly operator convergent if Tnx converges strongly in y. So that is norm of Tnx minus T of x, this is tends to 0 as n tends to infinity. And number three, weakly operator convergent if Tnx, so this is here also for all x belongs to capital X, okay, and if Tnx converges weakly in y, so that is modulus of f of Tnx minus f of Tx, this tends to 0 as n tends to infinity for all x belongs to x and a belongs to y dash. So y dash means set of all linear bounded function in y. Okay. This is here convergence of sequence of linear operators. So this is in general three types. So first is here uniformly operator convergent. If norm of Tn minus t, this is tends to 0 as n tends to infinity. And number two, strongly operator convergent. If norm of Tnx minus t of x, this is tends to 0 as n tends to infinity and for all x belongs to capital X. And third is also weakly operator convergent. If Tnx converges weakly in y, so that is modulus of f of Tnx minus f of Tx tends to 0 as n tends to infinity, and where this is also hold for all x belongs to x and a belongs to y dash. So y dash means set of all linear bounded functional in y. Okay. So and here also you note that uniformly convergent imply strongly convergent, this imply weakly convergent, but converse is not true in general. Okay, but converse is not true in general. So weakly convergent does not imply in general strongly convergent, and strongly convergent does not imply in general uniformly convergent. Okay, now this is the theoretical concept related to this problem. Okay, now we are going to solve this kind of problem. So now look at here the operator here. So the operator here Tn and T both are bounded linear operators. So this is also given, these two operator also bounded linear operator, and Tn also defined by these sequences. Now look at this sequence of linear operator. Okay, so first you see that now T1, so T1 is here, so I take here x is equal to x1, x2 and so on. So what is T1? So T1x, so T1x nothing but x1, x1 and so on, and T2x, this is equal to here x1, x2 and x2 and so on, and T3x, this is equal to here x1, x2, x3, x4, sorry, x3 and so on. And this way we get here in general Tnx, so this is equal to here x1, x2, x3 dot 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 xn. So this is here xn minus 1, so xn, xn and this way. Okay, so this is our Tnx. Now look at here first option. Norm of Tn does not converges to norm of T as n tends to infinity. So now we going to calculate what is here norm of Tn. So norm, so that means norm of Tnx. So this is equal to, so this is infinity here, x1, x2 dot 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 xn minus 1 and xn and so on. So this is equal to supremum of 1 less or equal to k less or equal to n mod of xk. So now limit n tends to infinity norm of Tn. So this is equal to limit n tends to infinity supremum of x belongs to L1 and norm of x1 not equal to 0, norm of Tnx infinity by norm of x1. So this is equal to limit n tends to infinity supremum of x belongs to L1 norm of x1 not equal to 0, and this is equal to here supremum of modulus xk 1 less or equal to k less or equal to n by norm of x1, and this is equal to here supremum of x belongs to L1 norm of x1 not equal to 0 supremum of 1 less or equal to k less than infinity. So that means I write here this is here k belongs to capital N such that supremum of x belongs to capital N modulus of xk divided by norm of x1, and this is nothing but this is here norm of t. So from here we conclude that norm of Tn tends to norm of t as n tends to infinity. So that means the first option become incorrect. Okay, so first option become incorrect. Now look at here second option. So second option also given that norm of Tn minus t tends to 0 as n tends to infinity. Okay, now what is our tx? So tx is here x1, x2 and so on. So norm of Tnx minus t of x, so this is equal to 0 0 0 xn minus xn plus 1 xn minus xn plus 2 and so on. Take x equal to 0 0 0 1 0 and so on. So this is your nth term. Then norm of Tn minus Tx, so this is equal to so then this x belongs to also L1 with norm of x1 equal to 1. Okay, so norm of Tn minus Tx, so this is equal to norm of 0 0 0 and 1 1 1 and so on this infinity, and this is equal to here 1, and this is equal to here norm of x1. So this implies norm of Tn minus t x divided by norm of x1, so this is equal to 1, and this implies norm of Tn minus t, so this is equal to here 1. But here also given that norm of Tn minus t tends to 0 as n tends to infinity, but if we take x is equal to in this form, then here we see that norm of Tn minus t this tends to 1 as n tends to infinity. So that means the second option become false. So B also false. Clear? Now look at the third option. For all x belongs to L1, norm of Tnx minus Tx, this is tends to 0 as n tends to infinity. So that means this is also a strongly convergent linear operator. Okay. Here also you see that T is also a bounded linear operator with norm of t is equal to 1. And why norm of t is equal to 1? So this is left for exercise. Please try yourself. Okay. And if you don't able to prove it norm of t equal to 1, then write in comment box. I definitely try to help you. So this is here T is also boundary linear operator, and I claim that norm of T equal to 1. And why norm of T equal to 1? So this is left for exercise. Okay. Now norm of T n x minus T of x. So this is equal to, and this is equal to, so this infinity, so this is equal to 0, 0, 0, xn minus xn plus 1 and xn minus xn plus 2 and so on. So this infinity. So this is equal to supremum of j belongs to n modulus of xn minus xn plus j. Okay, so this is here norm of Tnx minus Tx. Now you also know that x belongs to L1, so that means summation n equal to 1 to infinity modulus of xn, this is less than infinity. So let us choose, so this imply limit n tends to infinity xn, this is equal to 0. So let us choose epsilon greater than 0. Then for a pre-assigned epsilon greater than 0, there exists capital M belongs to n such that modulus of xn minus 0, this is less than epsilon for all n greater or equal to m, and n plus j, this is also greater or equal to m for all j belongs to capital N. So modulus of xn plus j, this is also less than epsilon for all x greater or equal to m. Now using these two results, we get modulus of xn minus xn plus j, so this is less or equal to modulus of xn plus modulus of xn plus j. Okay, and I take here this is here epsilon by 2 and this is here epsilon by 2, so this is less than epsilon for all n greater or equal to capital M and j belongs to capital N. So ultimate we get here norm of Tnx minus T of x, this is equal to supremum of j belongs to capital N modulus of xn minus xn plus j, so this is less than epsilon for all n greater or equal to m and j belongs to capital N. Since x is an arbitrary element in L1, so norm of Tnx minus T of x, this is tends to 0 for all x belongs to L1 as n tends to infinity. So that means third option become correct. Now if third option is also true, then you also know that if a linear operator, if a sequence of linear operator is strongly convergent, then this is also weakly convergent. But here you see that for For each non-zero x belongs to L1, there exists a continuous linear of functional g belongs to L infinity such that g of t n x not converges to g of tx as n tends to infinity. So that means option D become false. Okay, so our correct option is here C. Okay, so this is the way to approach this kind of problem, and I hope you got the idea. And if you face any problem, write in comment box, or you also send me problem through mail, and I definitely try to help you, and thank you very much. Okay.